All right, so in this video, we want to prove these trig identities. So let's start with the first one over here. I'm going to work with the left side because it's more complicated. I know I can convert cos square beta plus sine square beta into 1 using my trig identity. This is going to simplify to tan square beta plus 1. Then I can switch tan square into sine square beta over cos square beta plus 1. I'll continue over here. I'll make a common denominator next. So I'll multiply the top and bottom by cos square beta here. So I have sine square beta plus cos square beta divided by cos square beta. Then I know sine square plus cos square is just 1. My final answer is 1 over cos square beta, which is basically the same as the right side. Let's take a look at this second question over here. There's a couple of different ways to do this question, but I like to use the compound angle formulas, your addition and subtraction formulas. So I'm going to simplify this side. This is going to turn into sine pi over 4 cos x plus cos pi over 4 sine x. And then this is going to turn into sine pi over 4 cos x minus cos pi over 4 sine x. These two terms are identical but with opposite signs, so I can just cancel them off. And I'm just left with sine pi over 4 cos x plus sine pi over 4 cos x. Sine pi over 4 from your special triangles or from your calculator is basically 1 over root 2. Or if you simplify that, it's just a root 2 over 2 cos x plus root 2 over 2 cos x. And if I add these up, it's just going to give me 2 root 2 over 2 cos x. I just combine the two like terms. These two cancel, and I'm just left with root 2 cos x, which is also basically the same as my right side. Let's go to the third and final example. So I have sine over here with an addition and subtraction formula, and I have cot over here. Now, cot can be converted into cos over sine, or it can be converted into 1 over tan. You might be tempted to do 1 over tan, but the problem is in later steps, you cannot do tan of pi over 2 because that is an asymptote, which means that we have to convert this to cos over sine in order to solve this problem. So I'm going to write as cos pi over 2 plus x divided by sine pi over 2 plus x. Next, I'm going to use my compound angle formulas to split these up. Since these are multiplying and dividing, make sure to write them in factored form. So I'm going to have sine pi over 2 cos x minus cos pi over 2 sine x all inside a bracket. Then this one's going to be cos pi over 2 cos x minus sine pi over 2 sine x, again inside a bracket. And the denominator is just sine pi over 2 cos x plus cos pi over 2 sine x. So sine of pi over 2 is just, let me do that in my calculator just to make sure, it's just positive 1. So here I have 1 times cos x, which is just cos x. And cos of pi over 2 is just 0. This is just cos x minus 0 because 0 times sine x is just 0. This is also going to turn into 0. This is just negative sine x. And then the denominator here is just 1 times cos x is cos x. And 0 times sine x is just 0. So we can simplify this a bit. It's just cos x times negative sine x over cos x. And then these two coses just cancel, and you're left with negative sine x, which is basically the same as the right side.